One type of quiz that Canvas has available for us is what they call a formula question in a quiz that will allow you to generate questions randomly so that two people may be asked the same question but with different numbers in the question so that their answers are different. They still have to perform the same computations, but because they have different numbers in their questions, their answers will also be different. I wanted to show you how that works, so I'm going to create a quiz here. We'll give our quiz a name. I'll just call it Math Quiz. We'll give the people who take it some instructions, and let's add a question to it. The questions in a quiz can be a variety of different types of questions. You could have a multiple choice question, and then the next question might be a true-false, and the next question might be a matching. You can have multiple kinds in the same quiz. For our purposes here, I'm only going to use one kind. I'm going to use what's called the formula question. Right above it, the numerical answer would be if you want everybody to have the same set of numbers in their equation, in their question, so that they all have the same answer. A formula question will randomize it, and I'll show you how that works. So if I choose a formula question, we get some instructions here. The instructions say to build a formula, and it'll generate some answer combinations. The students will see a randomly selected set of numbers in where those variables go, and they have to put in the correct numerical answer. They have a very, very basic example here. I'm going to show a couple that do a little bit more. So let's start with the first question. Maybe I would ask something like, what percent of 200 is 58? But if I type it in like this, then everybody who takes this quiz will get those numbers in their question, 258, which means they will all have the same answer. And maybe I would like it to be shaken up a little bit so that different students have different numbers in their questions, even though it's really the same question for each person. So instead of putting the actual numbers in here, I'm going to replace those numbers with variable names. So this one I will just call big, and I'm going to put that inside square brackets, and then this one I'll put inside square brackets, and I'll call it little. Okay, so now what percent of the big number is the little number? And notice as soon as I put something in here with square brackets around it, because I've chosen this formula question, Canvas recognizes those as variables and creates this little section right here. Variable definitions. And so now it shows the names of the variables I've created, big and little, and it asks me to give a range of values that it can use to generate numbers to put into those variables. So by default, it says any variable, it just says I'm going to use numbers from 1 to 10. In this particular example, I want big to be big. So maybe the smallest I want it to be is 180, and I want it to go up to 300. And I could say generate numbers with a decimal point, or I can say 3 decimal places behind it, or I can just say, hey, make it a whole number, no decimals. And so I'm going to leave it with 0 decimal places right now. And you can see over on the right-hand side, it's showing me an example of a number that it would pick in the range that we're talking about. So between 180 and 300 with 0 decimal places, it says, hey, one example is 234. Fine. Okay, so I'm going to do the same for the little. And let's see. I want it to be no smaller than 15, just so that the percentage doesn't get too small. And because this is the little, I don't want it to ever get bigger than the big. So I'll stay underneath 180. We'll say 150. That way, because it's between 115 and 150, it doesn't matter what number it chooses for the big, it'll still be smaller, so that's fine by me. And an example is 34. Okay, but now the important thing is Canvas needs to know, how do I know if the answer is correct? And so here's where you put the formula in. I want to know what percent of the big is the little. So I'm going to take little divided by big, and because I want it as a percentage, not a decimal, I'll multiply it by 100. And I'm not going to have them put any decimal places on their answer, so up here in the instructions I'll say round your answer to the nearest whole number. When I click save here, it shows me that with these example variable numbers, the answer would be 15%. Now you tell it how many different possible combinations of the variables do you want me to go ahead and build for you. So I would say just do one for each person in the class. Seems like that would make sense. You can't go over 200, but I'm not sure why you ever would need to. So I'll say, hey, make 30 different possible combinations for this. And now for the answer, an error margin. So do you want them to get this number exactly, or are you going to give them a little bit of wiggle room? So maybe because if the answer is 41.5, they might write 41 instead of 42, since I'm telling them to round. Maybe I'll give them a error margin of plus or minus 1. That depends on what you've covered in class and how you've instructed them to do their rounding. You can change that error margin whatever you would like. Unfortunately, it's not possible to give it an error margin of a percentage. That would be nice, plus or minus 5%. So it's just a straight number that is your error margin. And so once you click generate, it gives you a list. Somebody's going to get the question with a 209 and a 26, and the answer would be 12 plus or minus 1. So if they put in 11, 12, or 13, they'll get it right, and so on and so on. And I'll update that question, and it's in there. Now I'm going to create one more just to show how you can build some more interesting formulas here. So maybe I'll do an ideal gas law equation. So something like 5 liters of an ideal gas that starts at STP is heated to I don't know, 100 degrees Celsius, and the pressure increases to 1,000 millimeters of mercury. What's the new volume of the gas? And I want your answer with 1 decimal place on it. And since there's not a way for them to type in their units, I'll specify that their numbers should be in units. Okay, in liters. All right, well, so first off, I need to make sure this is a formula question. And I haven't put any variables in here. So I'm going to change this to our original volume, so I'll call it V1. I'm going to change this to our final temperature, so I'll call it T2. And I'll change this to our final pressure, so we'll call it P2. And V1 from 1 to 10, I don't think I want it to go as low as 1, maybe 3, but 10 is fine for an upper end. T2, that's what we're heating it to. So it needs to be more than 0 because standard temperature and pressure. I'm starting at 0 degrees Celsius. That's what standard temperature and pressure means. So I'm heating it up from there. Let's heat it up at least 40 degrees and no more than 150 degrees. And then pressure. Okay, so pressure at STP is 760 millimeters, and we're increasing, so let's make it a significant increase by saying it's at least 900, but no more than, I don't know, 1500. Okay, well, so now I can put in my formula here. And the formula for this is essentially just P times V divided by T has to equal P times V divided by T, where these are the initial pressure, volume, and temperature, and these are the final pressure, volume, and temperature. So we'll replace these with what we need them to be. The initial pressure, if it starts at STP, is 760. The initial volume is what I'm calling V1. So I'm going to put a 1 after that V so that it's using this variable. The initial temperature, because we're at standard temperature and pressure, is 0 degrees Celsius, which is 273 degrees Kelvin. Not degrees, just 273 Kelvin. The final pressure is P2, so I'll put a 2 after that. The final volume is what we're looking for, so I'm just going to leave that. Actually, I'll put a question mark there because that's what we're looking for. And T is our final temperature, so that's T2. But T2 is in Celsius, and I need it to be in Kelvin. So this is not just T2 here. This is actually, I got to take T2 and add 273 to it to make it Kelvin. Okay, well, Canvas is nice that they can do these formulas, but they can't do this formula the way I've got it typed in because it's not solved for my variable. So what I need to do is multiply this to the other side. Since I'm dividing it by it over here, I need to multiply it over here. So I'll just type that out at the front, T2 plus 273 in parentheses, and that's getting multiplied. So I've multiplied that over to the other side. And then I got to divide by P2, so I'll divide by P2, which means it's not over here anymore. And now I've solved for my variable. I don't actually need that in the answer there, so I can just take it out. And because in the instructions I said round to the nearest tenth, we'll put that there, and we'll save it. And it says 4.1 is one possible answer. Well, that seems reasonable to me. Okay. Let's give it 30 possible values, and because I'm having it round to 1 decimal place, my error margin, you know what, I'm going to be a little bit lenient, and I'm going to give them 2/10 in either direction. When we generate this, 4.2 plus or minus 0.2, 4.6, you can see the different possible answers that students will get when they take this quiz. We'll update this question, and I'll save the quiz. And just so that we can see what it'll look like for a student rather, let's preview it. That puts us kind of in the student view. So now I'm taking this quiz. And notice it has replaced the numbers with the variables with numbers here. What percent of 299 is 139? Well, let's see. That's about 43%, I'm going to guess. 4 liters of an ideal gas is heated to 124. Boy, this is tough. I don't know, 5.1. And we'll submit the quiz. And you can see, on this one I answered 43. The correct answer with these two numbers should have been 46. And with the margin of error, if I had guessed 45, 46, or 47, I would have gotten it right. Here I guessed 5.1 because I didn't want to do the math. If I had guessed anywhere from 4.0 to 4.4, I would have gotten it right. So I failed this quiz. I got 0 out of 2. Hopefully that helps you see how the formula questions on a quiz work. They're pretty nice. One place that you should take a look at if you're interested in these kinds of questions is when you choose that and you get this set of instructions, this need help right here, pops up some information including what I think is the nicest part over here under functions, a list of the possible functions that you can have it do for you. So if you want it to do sine or cosine or tangent, you can just put those in there like this, cosine of, and notice that it requires your angles to be in radians, so you may have to do some work to change the angles to radians. However, they do have that as an option. This is a good place to look if you're interested in doing some complicated formulas. Hope that helps. Good luck and Godspeed.